I built this Mortal Kombat-style fighting game in the Godot Engine using AI. From the first prompt to the final playtest, the process took 5 days, around 50 meaningful prompts, 866 tool calls, and approximately 104 hours and 55 minutes of AI work. Here's exactly how the workflow went. I started by running Opus 5 inside the Claude Code desktop app using the Gauntlet loop. The idea behind this workflow is that the agent keeps inspecting and improving the game instead of stopping after the first result. I enabled maximum effort, connected it to the Fennara Godot MCP for screenshots and debugging, and gave it access to NoirStage for building and manipulating the 3D assets. As the build progressed, Fennara captured screenshots inside Godot so Opus could inspect its own work. It noticed things like the unfinished torch flames while also confirming that the wet floor, lighting, and depth of the arena were moving in the right direction. Meanwhile, NoirStage was being used to construct 4 original fighters, and Opus handled their rigging and animations. That first major pass ran for 13 hours and 52 minutes and used 183 tool calls. It created a character selection screen, 4 fighters, combos, blocking, special moves, enemy AI, multiple rounds, a HUD, and a complete arena. So at that point, I finally opened the project in Godot and tested the game myself. The environment looked surprisingly good, but the playtest exposed several problems. The original characters looked low poly, some of the skin was being pulled by the wrong bones, one character's texture was breaking, the controls weren't clearly explained, the character cards disappeared after a match, and the game didn't have any finishers. The core combat system was there, but the characters were clearly the weakest part of the build. That brought me to Meshy AI, which is also the sponsor of this video. I asked Opus to write detailed visual descriptions for all 4 fighters. I then used those descriptions in Meshy to generate 4 concept images for each character on a solid white background in an A pose. The fighters included Kryeth, the ice-based assassin, Magmar, the molten fighter, Vesper, the shadow assassin, and Tengu, the armored samurai. I reviewed all 4 image options for each character and selected the ones with the best proportions, cleanest clothing, and most visible hand details. I converted each selected image into a 3D model using Meshy's image to 3D workflow. Once the models were generated, I started preparing them for use in the game. My first retopology pass used quads at around 30,000 polygons. That worked for some of the characters, but Kryeth lost too much detail, so I regenerated that version using medium adaptive topology and triangles. That gave me a much better balance between visual detail and a mesh that could still be used inside a game. After optimizing the models, I textured them at 8K resolution. The difference was especially noticeable in the faces, armor, eyes, and smaller clothing details. At that point, the new Meshy characters already looked significantly better than the fighters Opus had modeled from scratch. Next, I asked Opus for a complete list of every animation used by the original characters, including how long each animation should last. I normalized the fighters to similar heights, moved their origins to the bottom, exported them as GLB files, and imported them into NoirStage. I manually rigged the first versions of all 4 characters. Tengu was the most difficult because his model had several layers of armor and overlapping pieces. After about an hour of working through the rigs, I realized that starting with Meshy's smart mesh workflow would have produced cleaner assets for animation. I still completed that first pass and asked Opus to transfer all 25 animation clips from the original fighters onto the new models. I also had it inspect the skin weights, correct visible deformation, generate combat audio through ElevenLabs, and add a controls menu explaining every attack and combination. By the time that pass finished, the total workflow had reached almost 30 hours. Opus had transferred the animations, added approximately 110 audio files, and created the controls menu. But when I tested it, the character rigs still had visible problems, some animations felt unnatural, and the generated voices made the game feel too obviously AI generated. I removed the character vocals, kept the usable sound effects, and went back to Meshy. This time, I used the Meshy AI agent to regenerate all 4 characters as optimized smart mesh assets, texture them at 8K, and prepare them for rigging. The AI agent also made it easier to iterate on several visual problems. One character had missing fingers, Vesper had an unwanted ponytail, and Tengu had helmet and armor pieces that weren't connecting properly. I described each problem in the chat, and the agent revised the reference images and regenerated the affected models. Once the corrected models were ready, I rigged them and gave the Meshy AI agent the full animation list from Opus. I asked it to apply every available move and match the requested duration as closely as possible. It handled most of the animations and gave me a report explaining which ones were missing or different from what the game required. I downloaded the animated characters and sent them back to Opus along with Meshy's report. Opus replaced the previous fighters, adjusted their bones and proportions, and retimed the combat. Fast moves like jabs needed to feel immediate, while flinches, knockbacks, and interrupted attacks needed to react correctly when an opponent landed a hit. The next test was much better, but there were still smaller issues with camera framing, launch animations, duplicate hip movement, and a few missing grounded attacks. I continued testing each pass and giving Opus specific feedback until the fighting looked consistent enough to move forward. The next major part of the workflow was creating the finishers. I first asked Opus to map every possible character combination for selection animations, introductions, and finishers. The full plan came out to roughly 80 possible videos, so I decided to focus on the finishers first. Opus used the Higgsfield CLI with Seedance 2.5 and captured multiple screenshots of the characters and arena directly from Godot. It collected different angles, relative character heights, and clean shots of the environment so the video generator would have enough visual references. The first Magmar finisher was just a basic body slam, which didn't fit his character. I changed the prompt so he would split the ground open and drop the opponent into lava. That result was much closer to what I wanted, so I used the same character-specific approach for the remaining finishers. Vesper received a deadly kiss that turned her opponent into a skeleton, while Tengu summoned a Japanese dragon to attack and swallow his opponent. When I asked for sound effects without music, the generator misunderstood and returned completely silent videos, so I clarified that I only wanted the music removed. As the number of generations increased, I moved the workflow over to FL.ai so I could continue using Seedance 2.5. Some results still needed multiple attempts. Magmar's opponent fell into the lava unnaturally, and Tengu's dragon looked like it was eating its own tail, so both sequences had to be regenerated. Once I had one strong finisher for each fighter, I used those videos as templates and generated matchup-specific versions with the other opponents. I also corrected Vesper's scream, removed distracting artifacts, trimmed sections that stayed on the ground too long, and instructed the game to play the winner's finisher automatically after each match. I then returned to the regular combat audio. Several projectile sounds were metallic, high-pitched, and more appropriate for an old arcade game. I replaced them with shorter action combat effects and kept the sounds that already worked, including Vesper's shadow projectile. The idle animations also needed another pass. I gave every character a different fighting stance, but the first results made them look like they were floating around drunk. I asked Opus to keep their feet planted and use grounded animations from Meshy, NoirStage, or a custom animation where necessary. For the music, I selected one track for the character selection screen and another for the actual fights. I asked Opus to balance both tracks against the sound effects and ease them in and out so the transitions didn't feel abrupt. The last major addition was putting myself into the game. I used GPT to turn a reference photo of myself into a full-body image wearing a fitted suit and standing in an A pose. I brought that image into Meshy and generated a private smart topology model at approximately 15,000 polygons. I textured the character at 8K and inspected the separated hands, shoes, clothing, hair, and buttons. I tried using the AI texture editor to improve my face, but the edited version stopped looking like me, so I kept the stronger original result. I then rigged the model, adjusted its height and center point, and added a fighting stance. To get my character working quickly, I mapped Kryeth's animation set onto it and matched their heights. I replaced the normal ice projectile with a subscribe button and created a custom finisher where my character smashes the opponent into the button before saying, "Thanks for smashing the subscribe button." I also went back to ElevenLabs and manually created a deep fighting game announcer. I generated separate vocals for each round: fight, finish him, finish her, KO, and every character's victory announcement. Opus then placed each line at the correct point in the match. The final testing phase focused on smaller bugs. My character was floating during combat, the fighter models disappeared from the selection cards after returning from a completed match, and some matchup finishers were missing. I had Opus fix the grounding, repair the selection screen bug, and generate every finisher variation involving my character. My generated finisher voice still didn't sound like me, so I replaced it with my real recording. Thanks for smashing that subscribe button. I also used my original photograph as the finisher reference instead of the rough 3D render so the cinematic looked closer to my actual appearance. After one final playtest, the character selection, combat, controls, announcer, music, sound effects, custom fighters, and finishers were all working together. The full build took 5 days, around 50 meaningful prompts, 866 tool calls, and 104 hours and 55 minutes of recorded AI work. The first Gauntlet prompt created the foundation, but the finished result came from repeatedly testing the game, identifying visible problems, rebuilding the assets, and giving the agents more specific direction. If you have an idea, you can Meshy it now and get a 60% discount by clicking the link below. Let me know what you think, subscribe if you want to see more builds like this, and I'll see you in the next one.